Alright, so that was the first part. Now the second part I'll show you guys with the oscilloscope here. Now oscilloscope will give you, like, show you what I was explaining so far theoretically, in drawings and all. Now, as we all know, this curly the curly I actually don't know what it's called, the curly waves, I'll call it curly waves. So only they can produce the PWM signals. And now this one base connected to the 11 pin, and then uh, the collector connected to this port. All right, then this port connected to battery emitter. All right, so let's see how it's working, if it's working. This is the code. Index equals to 0, then void setup pin mode 11 output, that's normal, void loop, and I've already explained the analog write function. On pin 11, I'm giving X signal, the data, and then delay of 1 second. Now X, I'm incrementing it by 5, and then giving an if statement. X, if it increases more than 255 is the max that we can give. All right, and minimum is 0. So 255, and again it will revert back to X equals to 0. All right, like, let's run the simulation. Nothing's working. All right, sorry, there was some mistake. I forgot to connect the ground pin. Again, I'll show you the connection. So here's the connection, and what I forgot was connecting the negative to the ground. It has to be a same ground terminal in order to work. Now let's see if it's working. Yeah, so this motor is working now. Now you can see the speed is increasing. All right, and here's nothing data. So the maximum, I think, will get somewhere around. You keep watching on this, watching the RPM. All right, so we're reaching 10,000. We'll reach around, I think, 16,000 or maybe 14,000. It might be 16,000. Like, just I want you to focus on the maximum RPM. Okay, so it reached somewhere around 16,000, I believe. And if you want to just check the maximum RPM, what you can do is stop simulation. This part you can keep it as commons, and then directly give this 255, because 255 is the highest. 255. Uh, Please remember this part, that uh, 0 to 255 is equivalent to 0 volts to 5 volt. Just a minute, sketchbook. Yeah, again, 0 goes to 255. This is equivalent to 0 volts to 5 volts, and this is equivalent to 0% of duty cycle to 100%. All right, so remember this part, don't forget this part. Now you are seeing that I'm giving it 100% duty cycle, so we'll get the maximum rotations per minute or maximum speed. So this is the maximum speed that we're getting, 17,552. All right. Now, in some cases, you will find that the RPM is not 17,000. Although you are using the same components, the RPM is not 17,000. What happens is that in transistor output and input characteristics, if you make the connections properly, you will get the maximum current. All right, and maximum current. I hope you guys remember. I think it was I is equals to IC plus IB, the transistor current equation. I'll just check. IC is equals to. All right, sorry. The transistor equation, I totally forgot. Transistor equation is emitter current equals to collector. Oh, sorry. Hmm. Uh, okay. Huh. So, collector current is equals to emitter current, all right, plus mm, plus IB is equals to, okay, sorry, IE equals to IC plus IB. I was correct in the first part only. Why I said that. So this is the equation that we are getting, and mm, I is equals to IB plus IC. So this is the equation that we have. So to get the maximum current, we need to know some electronics, simple electronics knowledge to get the maximum RPM here. Now what I'll do is I will connect the oscilloscope to show you guys what exactly is happening, what the pulse width modulation actually is. So I'll connect here and here. Alright, now the delay, what I'll do is I'll decrease it to 100 milliseconds just to show on the oscilloscope, and I'll start with 0. 0 according to this conversion is 0 volts, and that means 0 duty cycle. Now check the oscilloscope, you'll find a simple line and 0 RPM, so no speed. Now 255 is 100%, right? So uh, if you divide 255 by 4, you will get 25% duty cycle. So we'll use a calculator here. So 255 divided by 4, you will get 63.75. What we'll do is round it off to 64. All right, so 64. Now we'll start simulation, and wait, we need to go 500. Huh. So now you can see this duty cycle here, this thing. I'll use pen. Okay, so uh, this here that you're seeing, this part, this is nothing but 25% duty cycle. All right, and in terms of 0 to 55, this is 64. Okay, in voltage also you can